Hello, algebra students. Mr. Lawrence here with your next flip lesson. We've spent a couple days on story problems, and we're going to get into something called direct variation, and it's really simple, and you actually already know how to do it. You just may not realize you already know it, um, and it has some story problems involved in it, but it's real simple stuff. So the first thing you know about direct variation, it means if x increases, then y must also increase. Now, don't miss the subtlety here. X is just some variable, right? And what's going to happen in these story problems, we're going to have two variables. We may not know what they are right off the top of our head, but we're going to read the story, figure out what the variables are, and see is one increasing while the other one is increasing. For example, a story might look like this. The faster you drive, the more gas you use. So the two variables, one would be x would be like the speed or how fast you're going, and that's going up. And what happens when you go up the other variable is the gas you use, the amount of gas you use, that's the y variable, and that is also increasing because as your speed goes up, the more gas you use. That's an example of direct variation. Now when two variables vary directly, they can fit an equation that looks just like this. Y equals kx. Now this equation should look super duper familiar to you. You should be wondering, is this the same thing as another equation I already know? And yes, it is. It is the same thing as y equals mx plus b. You should be able to realize that there is no b because the starting point is 0. So technically it's like a plus 0. And that m is the slope. Well, k is like the slope. Now, we don't call it the slope when we're doing uh, direct variation, but it still is the slope. It's the constant of variation. Okay? You're going to see problems that look like this. It'll say x and y vary directly. Okay? Um, if x equals 10 when y equals 15, find x when y equals 20. All right. Well, a problem like this is super duper simple. You're going to use this equation y equals kx. And the first step is going to be solve for k. You have to find the constant of variation. I know x is 10. I don't know k. And y is 15. So I'm going to divide by 10 on both sides. And then k is going to equal 3 over 2. 15 tenths is 3 over 2, right? Okay. Second step, use k. Oops. Use k and y, the second y, to find the second x. So I'm going to use y equals kx. I'm going to plug 20 in for y. K is going to be 3 over 2. And then I'm going to multiply by x. I'm going to divide both sides by 3 over 2. And so we should know that 20 over 1 divided by 3 over 2 is the same as this. And that's going to give me 40 thirds. 3 is going to go into 40. Let me see here. How many times? Feeling a little slow. 16, I think. No, that's too many. 13 would be 39, right? So it's going to go in 13 times, and there's going to be one left over, 1/3. Okay, so that's what x will equal, 13 and 1/3 when y equals 20. So let's do another example. Remember, we're going to use y equals kx. Let's assume that x and y vary directly. x equals 30 when y equals 5. Find y when x equals, I don't want to go 20, let's go 10. Okay, so first thing I'm doing, I'm going to use this first information to find k. So I'm going to go 5 equals k times 30, right? I'll divide by 30 to get that k is going to equal 1/6. Now, y is going to equal 1/6 times 10. I can simplify and turn that into a 3 and that into a 5. And that'll get me that y is going to equal 5/3, or better yet, 1 2/3. And there you go. It's that simple. Now you may have a story problem that says, hold on one second. Okay, take a look at this example. The faster you drive, the more miles you cover in the same amount of time. That's an example of direct variation, right? Your speed is increasing, so your distance is also increasing, right? And in which case, the faster you drive, that's like your x variable, and the more miles, the distance, that's like your y variable. Now the same amount of time would be your constant, okay? Below, a table shows the speeds or distances of 3 different people that each drove for 3 hours. So let's take a look at this. Find the missing information. Bob drove 45 miles per hour for 3 hours. What distance did he travel? We have to figure out the distance. Sue, in 3 hours, went 165 miles. And then Georgia drove for 60 miles. Drove 60 miles per hour for 3 hours. Now, you may not realize this, but our new equation is y equals kx, right? Okay. And that's the same equation as y equals mx plus b, where the b is 0 and m has been replaced by k, but it's the same thing. Well, there's another form of this equation that we typically use, and you'll see this in science class, where you have distance equals rate times time. Okay, it's the same problem. The rate is the miles per hour, right? Well, that's like a slope. You go so many miles in 1 hour. You go so many more miles in another hour, right? And so what ends up happening is oops, I should use an arrowhead, it'll work better. You end up getting something like this, okay? Where the distance and then the time. I'm sorry, distance and then the rate, and the distance and the rate, and the distance and the rate. And you end up getting a slope. Okay, so I'm going to go ahead and use this equation, but note that most people would probably use that one in this case. All right, so I know my 45 miles per hour is my x variable. Okay, and my k is 3 hours. I want to know the distance that was traveled. If I was doing it over here, it would be distance equals the rate, 45 miles per hour, times the time. Same thing, because 33 times 45 is the same as 45 times 3. So the distance I'm going to get is 45 times 3. Well, let's see. 40 times 3 would be 120. 3 times 5 is 15. It looks like that'll equal 135. I just used the distributive property and did 3 times 40 plus 5. So I did 3 times 40 to get 120, and then I did 3 times 5 to get 15, and that's how I get 135. So the correct answer there is 135 miles in the 3 hours. All right. How would it work for Sue? Well, it's the same problem. Same problem. Hold on one second here. Okay, in Sue's case, we know she's gone 165 miles. We know that she's going to drive for 3 hours, but we don't know how fast she's going. We're going to divide by 3. If we did it over here, we'd have the distance, 165. That would equal the rate, which we don't know, times 3 hours, and we divide by 3. See, it's the same exact problem. Okay, it's just being able to recognize, oh, this is just y equals mx plus b, where b is 0. That's all this is. All right, so let's see here. 165, 3 is going to go into there 5 times. It looks like 55 times. So that means she's traveling at 55 miles per hour. Now, I know this last one, a lot of you will just kind of reason out. You'll say, hey, 60 miles the first hour, 120 miles the second hour, 180 miles the third hour, and you are absolutely correct. Just to prove that it works, we could do y equals 3 times 60. And 3 times 16 is 6 is 18. 3 times 60 is 180. And there you go. All right. That's your lesson for today, direct variation. We're going to get some practice with problems on that. And this will be Mr. Lawrence signing off. Good night, everybody.